Hello everyone, this is Abby and Brooke here, and we are the Crystallite Sisters. Today we're discussing the story of a woman of impact, Kathleen Yardley Lonsdale, who broke barriers in her field, changed communities, and took many inspiring actions. Kathleen was born in Newbridge County, Kildare, Ireland on January 28, 1903, to Harry Yardley and Jessie Cameron. She was the last of 10 children. Her father was an alcoholic, so her mother divorced him and moved the entire family to London when she was 5. She attended Downshaw Elementary School from 1908 to 1914, and then attended Ilford County High School for girls. The girls' school did not offer STEM courses, so Yardley transferred to the county's all-boys school to study mathematics and science. At the age of 16, she enrolled at the University of London's Belford College for Women, where she received her Bachelor's of Science degree in 1922. Yardley then went on to earn a master's degree in physics from University College of London, and eventually a doctorate degree in science at the Davy Faraday Laboratory of the Royal Institution. After university, she fell in love and married Thomas Lonsdale, who was a researcher in engineering and supporting his wife's research. In 1924, Kathleen joined the crystallography research team at the Royal Institution, which was headed by William Henry Bragg. During this time, Lonsdale worked with her lab mate, William T. Asbury, to create crystallography tables. A few years later, after extensive research and time, she discovered that the benzene ring is flat by using X-ray diffraction methods. The benzene ring was a molecule scaffold with unusual chemical properties that was considered a mystery to chemists for many years. It was the simplest aromatic compound, but it was in liquid form.
So in order for Lonsdale to discover that the benzene ring was flat, she had to use benzene derivatives of the same core of 6 carbon atoms. For example, one derivative that she used was hexylmethylbenzene, which could readily form crystals, making it perfect for her study. On the left side, in the blue, we can see the structure of 6 carbon atoms for benzene, which is a liquid form, as it compares to the right side in yellow of the 6 structure carbon atoms for hexylmethylbenzene, which is a solid form. After her big discovery, Yardley decided that she wanted to grow her family with her husband Thomas. From 1929 to 1934, she worked from her home and continued her work of calculating structure fractures. Once her children started to age, she made the decision to return to work with Bragg at the Royal Institution as a researcher in 1934.
Majority of Kathleen's research was completed using X-ray crystallography, which is a technology that was discovered in the 20th century that allows scientists to see atoms and their spatial arrangement within a molecule. She based a lot of her research on the theory of space groups, which helped determine where possibilities of molecular symmetry might occur, and demonstrating for the first time that the benzene ring was hexagonal and planar, and calculating its precise dimensions. She used X-ray diffraction to work out the structure of lots of chemicals and used X-rays to study crystals. X-ray diffraction is a technique to assess the crystallinity and structure of solids in a three-dimensional way. Lonsdale remained working at the Royal Institution as a researcher until she was appointed as a professor of chemistry and head of the Department of Crystallography at the University of London.
With Lonsdale's many achievements that included but are not limited to developing several X-ray techniques for studying crystal structures and proving that the benzene ring was flat by using derivatives of benzene, she was also able to perform all of her calculations by hand, and wrote and published many papers, such as a chapter published by the International Union of Crystallography and a summary in the book Nature. Her discoveries led her to many further examinations of synthetic and natural diamonds, kidney stones, developing a technique known as divergent beam X-ray photography, and studying solid-state reactions.
Since Lonsdale had many accomplishments, her reputation grew swiftly. In 1945, she was one of the first women to be made a fellow member of the Royal Society after physicist John D. Bernal, who worked on X-ray crystallography applied to molecules of life, spoke in support of Lonsdale's nomination by saying, "Kathleen, despite her unobtrusive ways, had such an underlying strength of character that she became from the outset the presiding genius of the place. Her opinions were sought for and her judgment was always respected." The Royal Society is a UK society that awards and nominates individuals for promoting excellence in science for the benefits of humanity.
Then a year later, in 1946, she was elected an honorary member of the Women's Engineering Society in recognition for her brilliant and important work. Then 3 years later, at her alumni, the University College of London, she became the first woman professor and rose to be the first woman professor of chemistry. At the university, she also established the crystallography department. A few years later, in 1966, she had been elected to be the first woman president of the International Union of Crystallography. A year after that, a rare brownish-yellow meteoritic diamond that was founded by Diablo was named Lonsdale, in Lonsdale's honor because it consisted of microscopic crystals that were associated with the ordinary diamond.
Lonsdale knew her finding would lead to many more revolutionary discoveries to be concluded. So, as we close this wonderful discussion about Kathleen Lonsdale, I want to leave you with a quote that she once said that all individuals in the science field should live by. "I believe in good, not just as a hypothesis, but as absolutely fundamental to all my way of life. A scientist should take interest in national and international affairs, not as politicians, but in making sure that facts are properly known, and trying to ensure that science is used for good." Thanks for watching!